So question 13 now related to this November 2014. The diagram shows four beakers are there. Four molecules are labeled the relative amount of energy in each molecule. Which molecule most likely to escape? So first thing during evaporation, number one, it should be molecule which are at the surface and the molecule which have the most energy. So most energetic molecules likely to leave the surface because they will have sufficient amount of energy to go out. So when we check the option, it cannot be C and D because C and D are at the bottom. So either A can be an answer or B. But because A is most energetic, A is having a greater amount of energy, that's why the A is likely to leave and go out from the water surface. So most energetic molecules at the surface will likely to leave the water during evaporation. And some gas is trapped in a container which is having a fixed volume. So here, like we have a container which cannot change the volume, and it is having particles, and what we did, we increase the temperature. So when we increase the temperature, when we supply the heat energy, the particle will move faster and they will hit the wall harder. So as a result, when the particle hit the wall harder, the pressure will also increase. So question is, which graph represent the change in the pressure and temperature? So as we increase the temperature, the pressure what it shows, A shows that the pressure is constant. That's wrong. What B is showing, it shows that the pressure is decreasing with temperature. That's wrong. C shows again pressure and temperature are inversely proportional, so wrong. And D, why it is the answer? Because when we are increasing a temperature, the pressure which the gas molecule exert on the wall of container increases. Then page number 8, any doubt? Page 8. This is just a straightforward graphs are there. Distance time graph, slope represents speed, and speed time graph, slope represent acceleration. Then page number 9, any doubt? On page 9. Figure shows a bungee jumping for a bridge. A person is attached to a long cord. When he jumps in 1.5 seconds, so this is a time, the speed of a jumper increases from 0, so it starts with 0 and it ends at 10.5. What is the average acceleration or total acceleration or maximum acceleration? All have the same formula. It's final minus initial divided by time. So final is 10.5, initial is 0 divided by time, which is 1.5. So 10.5 minus 0 divided by 1.5, this will give you the acceleration of the bungee jumper, which is about 7 meter per second square. Then at this point, at one point during a fall, she reaches her maximum speed. Maximum speed means after that speed won't change, because that means when I say a jumper reaches a maximum speed, say 10.5 meter per second is a maximum speed. It means after that the speed does not change, or after that speed does not increase. So state her acceleration. If an object reaches the maximum speed, it means it's not changing the speed after that. So if an object is not changing the speed, what about the acceleration? The acceleration of an object which is not changing the speed, that will always be 0. What can you say about the forces acting on this? So whenever the object is having a 0 acceleration or no acceleration, it means there should be no resultant force, or we can say the forces are balanced. So there is no resultant force or the forces are balanced when the object is having no acceleration. Is it clear, this question?
Yes, clear.
Because to change the speed or to accelerate, it need a resultant force. Another question, a diver climb uh, some steps on the fixed platform and he jumps, he dives, as you can see. The mass of a diver is 65 kilograms. The platform is 8 meter above, so he jumped from a height of 8 meter. Calculate the potential energy. Increase in potential energy, gain in potential energy, total potential energy. That is given by a formula. That potential energy is mgh. So mass is how much? 65. Gravity is how much? 10. And he reaches a height 8 meter, because when he jumps he's at this position, so he's 8 meter above the ground. That's why we use mgh. So 65 multiplied by 10 multiplied by 8, this will give us the gravitational potential energy or the potential energy of this swimmer, which is about 5200 joules. So it is 5200 joules of potential. The speed at which the diver hits the surface. Ignore any effect of air resistance. So if there is no air resistance, look, when the diver is at this point, so when he's at this point, he's having a potential energy, which is 5200 joules. But when he jumps, his potential energy is decreasing and his kinetic energy will increase. Before hitting, he will have the maximum kinetic. So all of the, because there is no loss in the question, they mention that because ignore the effect of air resistance, so it means there is no loss of energy. If there is no loss of energy, all of the potential energy will turn into kinetic energy. So if he was having a potential energy of 5200, as he jumps, before hitting the surface, he will have all kinetic energy, which is also 5200 joules, because energy cannot be created nor be destroyed. It changes its form from one to another. So we want the speed here. How to work out the speed? So we have the formula that kinetic energy is half mv square or 0.5 mv square. The potential energy was 5200 joules. So how much is the kinetic? It will be same kinetic, so it will be 5200 joules, because all the potential has changed to kinetic when he is coming down. Then 0.5 m is the mass of the diver, which is given in the question, the beginning of the question, which was 65. So mass is 65 multiplied by v square. So we simplify this, 5200 divided by, this is 0.5 into 65 is multiplied, other side will be divided. So 0.5 into 65 is equals to v square. But because it is v square, we need only v. So we'll take an under root. So when we take an under root, it will give us 12.6 meter per second, the speed of the diver. Also, there is also another way to solve this question. What is the second way to solve this question? Like, it will have a potential energy at the maximum height. When it is coming down, it will have kinetic. So we can say the potential energy will be equal to kinetic energy, or kinetic energy is equals to potential energy. The kinetic energy is given by a formula half mv square or 0.5 mv square. Potential energy is given by a formula mgh. So when kinetic and potential energy are same, this m can cancel with m. So we can also say that 0.5 v square is equals to gh. So you can also use this formula It is only valid when the potential energy is equals to kinetic energy. And you don't need a mass here. You can just substitute the value to get the speed. Is it clear, this question? That how we work out the speed of athlete or a swimmer as he jumped from the platform?
Sir, can you explain it
Yes.
again?
Okay. When this swimmer, he move up the stairs, because he is rising up, so he will have potential. So when we calculate the potential energy here, it was 5200 joules. And according to conservation of energy, energy changes from one form to another. So the moment he jumps, as he jumps, what will happen? Because he's coming down, so his potential energy start to decrease. And because he is moving and his speed is increasing, so it means the kinetic energy start to increase. So what was the potential energy at the maximum height will be same as the kinetic energy before he hits the surface. At the center, he will have half of potential, like half of 5200. 5200 is uh, 50, half of 5200 will be 2600. So this will be 2600 joule will be potential and 2600 joule will be kinetic. But when he come down, before hitting, he will have only potential energy, and he will have only kinetic energy, and there will be no potential energy. So basically all of the potential energy has converted into kinetic. So we have the kinetic energy, we need the speed. So how to get the speed? So kinetic energy is half mv square. The kinetic energy is 5200. 0.5, the mass is given 62 or 65 into v square. So 0.5 into 65, that is 32.5. So this is 32.5 and this is 5200 v square. 32.5 is multiplied, other side it will be divided. So 5200 divided by 32.5. So 5200 divided by 32.5, which is 160. So 160 is v square, but we need v. So we take a root both side. That will give us 12.6 meter per second, the speed at which the swimmer will hit the water surface. Is it clear?
Yes, it's clear.
In question 17, figure 3.1 shows an oil container containing only air at atmospheric. The atmospheric pressure is 1 exponent 5 and the pressure of the air inside the can has reduced to 6000 Pascal. Why the can collapse? So what is the reason why the can collapse? Like this is a can which is filled with air, inside also and outside air is as well. But inside air is having a low pressure which is only 6000. The outside air, the outside air is, they mention here the atmospheric pressure or the outside pressure is 1 exponent 5 or 100,000 Pascal. And pressure from inside is only 6000 Pascal. So because the 6000, the pressure from inside is less than pressure from outside, that is why the can collapse or can burst. The second part, the surface area of X is 0.12. Calculate the resultant force. So how to calculate a resultant force? So look, there are two pressures, one from inside, one from outside. So we need two forces as well. We'll calculate first the force from outside and then force from inside and then take a difference. Like what will be the force from outside? The pressure from outside is 100,000 Pascal. And the area of this can, the surface X is 0.12. Area of this part is 0.12. So what is the force from outside? The force from outside, that is pressure multiplied by area. So pressure is 100,000 times area is 0.12. So 100,000 multiplied by 0.12, that will give us 12,000 Newton. That's a force from outside, like force which is on the can from outside. So that force is 12,000 Newton. And when we calculate force from inside, because inside the pressure from inside is only 6,000 Pascal. So if we want to calculate the force from inside, so it will be pressure multiplied by area. The pressure is 6,000 multiplied by area is 0.12. So 6,000 multiplied by 0.12. So force from inside is 720 Newton. So force from outside is 12,000 and force from inside is 720. So if we want a resultant force, because the two forces are in opposite direction, whenever two forces are in opposite direction, to get the result we subtract. So 12,000 Newton minus 720, that will give us 11,280 Newton as a resultant force on this. Is it clear?
Yes, clear.
So whenever these type of questions are there, the object is there. So there are two pressures. One is from inside, one is from outside, and the difference in the pressure or the difference in the force is the resultant force or a resultant pressure. The mercury is poured. This is the last question. The mercury is poured in a U-shaped glass tube. Water is poured into another limb of a U-shaped glass tube. As a result, when you see this, the level of the mercury is same. The level of the mercury is same in both sides. We put one side we put water, another side we put oil. So what we can say, if the level of the mercury is same both sides, we can say the pressure exerted by the water is equals to pressure exerted by the oil. Water is exerting pressure, oil is also exerting pressure. Because the both side the mercury level is same, we can say the both pressures are equal. If it was like this, for example, the same question but the levels were like this, what we can say now? If it was like this, which pressure is higher? So if it is in this manner, it means the water is exerting more pressure and the oil is exerting less pressure. And if it was other way around,
The pressure of oil will exert more force than pressure of water.
yeah, the pressure of the oil will be more than water. But because in the question both levels are same, so we can say the pressure of the oil is same as the pressure of water, or pressure exerted by the oil is same as pressure exerted by the water. So what condition must be true? So you will mention here the pressure of the oil is equals to pressure of the water. The next part, the height of the water is 0.25, the density of the water is 1000, the height of the oil is 0.32. Calculate the pressure exerted by the water on the surface. So how to calculate the pressure exerted by the liquid? So whenever we are calculating a pressure exerted by the liquid, that is pressure is equals to density of a liquid, gravity and depth. The density of a water is 1000, gravity of the gravity of the earth is 10, and the height, that is 0.25. So 1000 multiplied by 10 multiplied by 0.25, that's equal to 2500 Pascal. That is the pressure exerted by the water. The next part, we have to calculate the density of the oil. So this pressure exerted by the water is 2500 Pascal. How to get the density of the oil? We'll also use the same formula. We already calculated the pressure which the water is exerting, that is 2500 Pascal. So if water is exerting 2500 Pascal, the oil will also exert the same pressure because the mercury level is same both sides. So oil is also exerting 2500 Pascal. Now to get the density of the oil, again same formula, pressure is equals to density, gravity and depth. So pressure exerted by the oil is same as the pressure of the water, which is 2500. The density of the oil is unknown. The gravity is 10 and the depth, how deep it is, 0.32. So this is 0.32. So 10 multiplied by 0.32 will be 3.2. So 2500 D into 3.2. 3.2 is multiplied, other side will be divided. So 2500 divided by 3.2, that is equal to 781 kilogram per meter cube. That will be the density. Is it clear, the last part, that how we work out the density of the oil?
Yes, it's clear.
Anyone else having a question or a doubt related to this weekly homework? So this was October, November 2014.
Sir, for the last question, the answer will be with kilogram per what? Because I didn't
Kilo,
hear.
kilo, kilogram per meter cube. Because if the length
Okay.
is in meter, if a length is in meter, then answer should be in meter cube. If length is in centimeter, then the answer will be in centimeter cube. But always remember, whenever you are using this formula, pressure is density, gravity and depth, this H can never be in other unit. It should always be meter. Always. The height, the depth should all, if in the question they give us in centimeter, then we have to convert into meter. So this is a
Okay,
common
thank you.
this is a common mistake what student used to make. Like say this was given 25 millimeter. So when student use the formula, they just use this value, density example 1000, gravity is 10 and they substitute 25. That will give you a wrong answer. So remember, whenever this formula is there, the height is always in meter. So this was a weekly homework related to October, November 2014 session.